This is a video on exponential graphing for Honors Algebra 2. Consider this function, f of x equals b to the x power, where b is a constant greater than 0 and not equal to 1. It's called the base. So b is some number. It's not a variable. It could be 2, it could be 1/2, it could be square root of 2. It's some number greater than 0 but not equal to 1. Because if it was equal to 1, 1 to any power is always 1, and this would be a very uninteresting function. It would just be the horizontal line at 1. X is the variable. X is the independent variable, and it is in the exponent of the equation, where b is the base of the exponent. So this is called an exponential function. And any function where the variable is in the exponent is an exponential function. What does this function look like if we graph it? Well, let's consider an example. Number 1, y equals 2 to the x power. So let's make a chart, since we don't know anything else about this graph. If x is 0, then I've got 2 to the 0 power, and anything to the 0 power is always 1. So I've got the point 0, 1. We'll plot that one. 0, 1. If x is 1, I've got 2 to the first power, and that's just 2. So when x is 1, y is 2. If x is 2, then y is 2 squared, which is 4. If x is 3, then y is 2 to the third, which is 8. If x were 4, y would be 2 to the fourth, which is 16, and that's off my graph, so I'm not going to bother with that. But what happens if x is negative 1? If x is negative 1, I've got 2 to the negative 1 power, a negative exponent means I put it on the bottom of the positive exponent, so it's 1 over 2 to the first power. That's just 1/2. Okay, so if x is negative 1, y is 1/2. If x is negative 2, I've got 1 over 2 squared, and that's 1/4. If x is negative 2, y is 1/4. And if you notice, if I take greater and greater negative numbers, so negative 4, negative 7, negative 10, I'm going to get a smaller and smaller fraction. It will still be a positive number, though. It's never going to be negative. A negative exponent doesn't make my number negative. But it's going to make it closer and closer to 0. So as x gets further and further negative, my graph gets closer and closer and closer to y being 0. So that's getting closer and closer and closer to the x-axis. So I can sketch the graph like this. It gets closer and closer and closer to the x-axis as x gets further and further negative. It's hard to draw. It looks something like that. That is the graph of this exponential function, y equals 2 to the x power. So that means that the x-axis becomes an asymptote, a horizontal asymptote, as x gets further and further negative. So anytime b is greater than 1, anytime the base is greater than 1, the graph of y equals b to the x will always have that same shape we just saw. It will always go through the point 0, 1, because if I plug in 0 for the variable, I'll have a 0 in the exponent, and that will always give me 1. It will always be increasing from left to right. We'll always have an asymptote of y equals 0, which is the x-axis, as x goes to negative infinity. So as x gets further and further negative. Its domain, the possible numbers I can plug in for x and get a number out for the function, is all real numbers. I can plug in anything I want for x. But the range is limited. The range will only be positive numbers. I will never get 0, because a number, positive number, to any power is never going to be 0, and I will never get a negative number either. So the range is a set of y such that y is greater than 0. Okay, well, that's any time that the base is greater than 1. The base, remember, had to be greater than 0 but not equal to 1. So we've handled the cases where it's greater than 1. What about if it's between 0 and 1? So for example, 1/2. Y equals 1/2 to the x power. So let's plot some points. We'll make a chart. What happens if x is 1? Well, then y is 1/2. What happens if x is 0? Well, I'll still get 1. 1/2 to the 0 power is 1. Anything to the 0 power is 1. So I've still got the point 0, 1. What happens when x is 2? Well, I'll have 1/2 squared. 1/2 squared is 1 over 2 squared, which is 1/4. It's really 1 squared over 2 squared, but 1 squared is 1. 2 squared is 4, so it's 1/4. If x is 2, y is 1/4. Alright? So it looks like as x gets bigger and bigger in the positive direction, I'm going to get closer and closer and closer to 0, closer and closer and closer to the x-axis, a smaller and smaller fraction. That will be the case. What happens if x is negative 1? Well, I'm going to have 1/2 to the negative 1 power, which means I'm going to take the reciprocal of my fraction, 2 over 1 to the positive 1 power, and that's just 2. So if x is negative 1, y is 2. What happens if x is negative 2? I'll have 1/2 to the negative 2 power, and that's the reciprocal, 2 over 1 to the positive 2 power, and that's 4. So if x is negative 2, y is 4. If x is negative 3, similarly, I'll get y to be 8. If x is negative 4, I'll get y to be 16. And my graph is going to look like this. Over here, it does not go below the x-axis. That's a mistake. But it will get closer and closer to the x-axis. So notice the only difference between y equals 2 to the x and y equals 1/2 to the x is that I have essentially flipped y equals 2 to the x graph over the y-axis. So this one contains 0, 1. It decreases from left to right. It has an asymptote of y equals 0. The x-axis as x goes to positive infinity instead of negative infinity. The domain is still all real numbers. The range is still only positive numbers, a set of y such that y is greater than 0. So that will be true any time that the base is between 0 and 1. Okay, I can also perform transformations of exponential graphs. Transformations mean I'm going to reshape or move my graph. So I form here of an exponential function. Y minus k equals a times b to the c times x minus h power. So the power is c times x minus h. The base is still just b. A is a number that I am multiplying by after I take the power. K is a number I'm subtracting out from y. H is a number I'm subtracting out from x. So I shift vertically by I shift vertically by k. I shift horizontally by h. If a is negative, if the number in front of the base is negative, I reflect it over the x-axis. If c is negative, if the number in front of x is negative, I reflect it over the y-axis. The absolute values of a and c determine the rate at which the graph increases or decreases. So let's see some examples. Let's describe the transformations and then graph it. Y minus 4 equals 2 to the x minus 3 power. So I'm subtracting 4 off from y, subtracting 3 off from x. Subtracting 4 off from y means I'm going to shift 4 vertically. So I'm going to shift up 4. Y up 4 because I'm subtracting off a positive 4. I'm going to shift right 3. The number I'm subtracting off from x determines the horizontal shift. Y right to 3 because I am subtracting off a positive 3. Okay? So I'm going to take the original graph, y equals 2 to the x. I'm going to move it up 4 to the right 3. So I know the original graph went through the point 0, 1. I'm going to move that up 4, which will make it 0, 5, and I'm going to make it to the right 3, which is going to make it the point 3, 5. That's what I mean by shifting. Every point of the original equation moves up 4, moves to the right 3. Okay? Y equals 2 to the x went through the point 1, 2. So I'm going to move that up 4 which will make it 1, 6, and to the right 3, which is going to make it 4, 6. Okay? It went through the point -1, 1/2. Well, now it's going to go through the point, if I shift it right 3, it's going to put me at +2, and then up 4 is 4.5. So +2 and 4.5. And that's the shape of this graph. But instead of approaching the y-axis, it's now going to approach and have an asymptote of y equals 4. So I have shifted the asymptote up 4. It was at y equals 0, now it's at y equals 4. The domain, then, is still all real numbers, but the range now, instead of being all positive numbers, the range is a set of all y such that y is greater than 4. It moves up by 4. It is shifted up by 4. So same shape, shifted to the right 3 and up 4, which shifts the asymptote and the range and every point on the line, on the graph. How about this one? Y equals -3 to the x plus 1 power plus 5. Let's move the 5 to the other side so it's in the form that I want it in. And let's realize that not being raised to the exponent. If I wanted it to be raised to the exponent, I'd have to have a parentheses around the -3. But I'm not going to do that. I have 3 to the x plus 1 power, and then I'm making that negative. So the -5 means I'm going to shift up 5. The +1 means I'm going to shift to the left by 1. I'm going to shift horizontally by -1, which is shifting to the left 1, because it's really x minus a -1. And then the negative means I'm going to reflect, and a negative in front of the base means I'm going to reflect it over the x-axis. I'm going to take every y value and make it negative. So reflect over the x-axis. So I could think of y equals 3 to the x and shift it, or I can make another chart. If x is 0, what happens? Well, I'd have 0 plus 1, which is 1. That's my exponent. I'll have 3 to the first, which is 3. I'll make that negative, so that's -3. So if y minus 5 equals -3, I'll add 5. It means y equals 2. So the point 0, 2. If x is 1, my exponent will be 1 plus 1, that's 2, and 3 squared then is 9. I'll have -9. Y minus 5 equals -9. I'll add 5 to the other side. Y equals -4. X is 1, y is -4. Okay? If x is 2, I'll have 2 plus 1, and that's 3, and 3 to the third power is 27, so I'll have y minus 5 equals -27, means I add 5 to the other side, and y equals -22, and that's way off my graph. I'm not going to plot that. What happens if x is -1? If x is -1, I'll have -1 plus 1. Well, that's 0. I'll have 3 to the 0 power. That's 1. We'll have y minus 5 equals -1. I'll add 5 to the other side, and I'll have y equals 4. So when x is -1, y is 4. What happens when x is -2? We'll have -2 plus 1, that's -1. I'll have 3 to the -1 power. That would be 1/3. So if y minus 5 equals -1/3, I'll add 5 to the other side, and I'll have y equals 4 2/3. X is -2, y is 4 2/3. I know that's a mixed number, but that's easier to graph than thinking of an improper fraction. Okay, so what happens when y is -3? I'll have -3 plus 1, that's -2. I'll have 3 to the negative 2 power. So that's 1 over 3 squared. That's 1 over 9. So I'll have y minus 5 equals negative 1/9. I add 5 to the other side. I have y equals 4 to the 8/9 power. Or 4 and 8/9. I'm sorry. 4 and 8/9. So this is going to get closer and closer to 5 as x gets more and more negative. That's a terrible graph. It's closer and closer to 5 as x gets more and more negative. Then it rounds down like that. So this time we're going down, and that's because we reflected it over the x-axis. So the domain here, the domain is still all real numbers. I can still plug in anything I want for x. But the range here is going to be the set of all y such that y is less than 5. Because I can't get 5 and I can't get over 5. Number 5. Y equals negative 1/2 times 4 to the negative x plus 3 power. Okay. So I'm going to make one adjustment to the way this is written, and that's to factor out the negative 1 in the numerator, or in the exponent. So I'll have negative x minus 3. That tells me that I've shifted to the right 3 and reflected it over the y-axis. So the negative up there means a reflection over the y-axis. While this negative in front of the 1/2 means a reflection over the x-axis. Reflect over the x-axis. So I'm reflecting over the y-axis and reflecting over the x-axis. I'm multiplying by negative 2, and I've shifted to the right 3. So what is this going to look like? Well, let's plot some points. And our graph looks like that. So as x gets larger and larger in the positive direction, the graph approaches the x-axis. It has an asymptote of y equals 0, the x-axis, as x gets larger and larger. But as x gets more and more negative, it gets more and more negative in the y direction. It decreases as we move from right to left, which means it's increasing as we move from left to right. The domain is still the set of all real numbers. No limit on what I can plug in for x, but there is a limit on what I can get out for y. The range is a set of all y such that y is less than 0. So we haven't shifted anything in the vertical direction, but we have shifted horizontally, and we've reflected a couple of times. So here are your immediate practice problems. Number 1, graph y equals 4 to the x power. Number 2, describe the transformations of this equation and graph it. Y plus 4 equals negative 2 to the x power. Number 3, using your graph, what is the domain and range of the equation in number 2? That's the end of this video on graphing exponential functions.